let's say you need to find the equation of a polynomial, but this time, instead of just being given regular zeros, you're given imaginary zeros. It's kind of fun, actually. So let's just say that you are given 1 and 5i, okay? Real quick, imaginary zeros always come in what are called conjugate pairs, right? We've been talking about complex numbers. And so complex numbers, they have a real part and an imaginary part, right? If you are given this complex number, it's the conjugate of that is just where you change the sign. Conjugate's always just where you change the sign. An easy way to remember it. They're always going to come in these conjugate pairs, okay? So if you're given the imaginary zero of 5i, the pair with that is just going to be the negative version of it. So I'm just going to add a negative 5i to my list here. So now let's find the zeros of these. You do the exact same thing you did before. You find the factors. And so this is going to be x minus 1, right? X minus 5i. Okay. And then x plus 5i. Now all we have to do is FOIL these out, right? Or it doesn't really matter what order you do it in, as long as this x gets multiplied by all these other 4 terms and the other factors, and as long as this -1 gets multiplied by everything in the other factors, and then this x gets multiplied in everything in the other 2 factors, and you go on and so forth, right? As long as you keep track, which I suggest you just cover one up, do these 2 first, and then everything that you get, then you can multiply it by this guy. Let's see, this time I'm gonna do a different kind of factoring. It's all, I think I kind of like factoring now. I'm gonna do the box method. I'm sure that lots of you have done the box method, and it's really popular. And it works really well because it uses a visual to look at space, right? This is like surface area. So I'm just gonna factor these out. I'm gonna start with these two. See, I look at this and I notice something. I recognize this is a difference of squares, right? Because I have the plus and, or sorry, the plus and the minus, and then I have x times x is gonna be x squared. And then when I do this negative 5i and this 5i, I'm gonna get 25i squared. So I'm kind of cheating because I really like noticing the difference of squares, but this is going to come out to be x squared minus 5i squared. That is the definition of the difference of squares. And then I'm going to see too that like I'm going to have an I squared when I get this power over to the 5 and the I. I'm going to have an I squared, and then I squared, if you recall, is just, pause the video, -1. So I squared is going to be -1. So I'm going to have -1 times then 5 squared and -5 squared. I'm going to get positive 5 squared, or like positive 25. But let's just make sure. I'm like thinking way ahead because I like to notice the patterns. So let's see, x minus 5i. And then x plus 5i. Okay, x times x times -5i and then x times positive 5i, and then negative times positive, I'm going to get negative, 5 times 5, 25, and I times I. Okay, boom. All right, and I do notice that this I squared, that's really going to be -1. So I'm going to have -1 times -25. This is just going to pop out and become positive 25. I'm just going to like make a note that that's really just 25. Okay, So now what else do I see? What else do I see? Ooh, you see how this is like a negative 5ix and this is a positive 5ix? It doesn't matter what order you write the 5 and the I and the x in, right? You could have written 5xi or x5i, because again, multiplication doesn't matter what order you do it in. But these are like terms. They're exactly the same, except this one is negative and this one is positive. So they cancel. And I'm left with x squared plus 25. Oh my gosh. Fabulous, fabulous, fabulous. Just like what we have up top. So now I have x squared plus 25 all. And now all of that, because that was all of this stuff, needs to be multiplied by the x minus 1. Okay. So again, you can use the FOIL method or OLIF or LOIF, I guess. I'm just going to do the box method one more time because if you like this and it works for you, then that's great. And I have nice, pretty graph paper. I mean, why not? Okay, so I'm going to start on one side with the x minus 1. And then the other side with the x squared. And then 25. Okay, x squared times x. Oh, obviously, pause the video, all the good stuff. X squared times negative 1. 25 times x. And 25 times negative 1. And now I'm going to get nothing cancels. I can't simplify anything. I'm golden. So I'm going to get x cubed minus, I'm going to write it in hierarchy. I'm going to go 3, 2, 1, 0. And that is your polynomial function. Let's call this glorious f of x. That is your polynomial function given zeros, even when zeros are imaginary.